From what you were telling, Mike, it seemed like the main problems initially were kind of related to the modeling part itself. When did it start becoming more data related, or were there data related problems as well from the very beginning?
So actually the data, so we took on the whole problem right from the beginning. And I actually remember us like thinking about and working on a feature store very early on. Um, but it wasn't, it took us a while to get our first things in production because there's a lot of stuff you got to build. We were starting from zero, and it wasn't until later that we realized the importance of all of the data things, the feature platform side of things. Um, so so, but certainly at first we thought it was about the models. We thought we're going to help people train models, productionize models, and we thought this was going to be like a model management system. And then we thought, maybe we'll have some like stuff that'll help people like build features faster. What we found though, after like when we really started getting this thing going and we really learned how to unblock data science teams, was that, well, okay, so what we found was we were helping these teams, and then as we were helping them, what we were doing all this manual data engineering work again and again, and that data engineering work was the same work. It was like the same thing again and again, and so we began, thinking, why don't we automate and centralize this stuff into the ML platform? Because the data engineering work that we were doing, and let's talk about what that is. It's like building the pipelines to compute features regularly. It's building the pipelines to store features and serve them quickly for real-time inference. Building the pipelines to compute these features for training time and assemble them into training data sets, to generate the training data sets, and building the pipelines to like monitor this stuff and log it and everything like that. We were doing that, for each different project, and then we were like, it's the same thing every single time. Let's just automate and centralize that into the ML platform. That's what we called feature store. We started calling it a feature platform, and it was pretty cool. Like we had, I remember one of our engineers going, "This is cool because now I can just make a bunch of features and have them kind of be like our central feature library for the whole company, for all of Uber." And I remember telling him, "That's cool. Like go do that." I thought he was going to make 12 features, and he came back the next day and he goes, all right, we have 6,000 features in the feature store already. And I was thinking, like, how did you do that? But he scripted something and it auto generated a ton of features. And those features became like the default features that someone would use in almost like every ML model. It was stuff like details about a rider, details about a driver, about a trip, like basic things that we had point in time values tracked so we could generate a training data set. It was already wired up for serving and training and stuff like that. And so the value of that is it allowed a data science project to hot start. There was not a cold start situation where they're like, I want to build a model. Okay, I'm starting from zero. Even if they didn't do any feature engineering, they had a central library where they could at least pull some really good data, some really good features about all of the business concepts that we have, and get something going and see, is it even possible to predict this thing? Of course, you will do like specific feature engineering if you have a unique data set and stuff like that. But that became like a really nice a really nice system that we added to the platform, and we started it pretty quickly, but we learned pretty quickly like the value of it, and it became a pretty central source of value in the whole platform. It was one of the things that attracted people to using Michelangelo at Uber.
To me, like the Michelangelo paper was almost about feature stores and feature pipelines, right? Because
Really? For me, it sounded like end-to-end
it,
platform. There was about serving, about deployments,
yeah.
monitoring.
But the initial picture, right? It's a lot about movement of data, how
Let's
it ends
ask
up.
author. Let's ask author. Is it
Yeah.
end-to-end or is it a feature store? Was it a
No,
feature
no, no.
store?
So,
Like,
so Michelangelo was about this end-to-end ML platform, and there's a bunch of like lessons there too. But like we were, we didn't think of our team as we're building a feature platform. We thought of it as we're helping teams build and deploy machine learning applications. And so we're the ML infrastructure group. So we weren't constraining it just to feature platform. But I think what you're referring to, Arimas, is like when you look at like what we actually, we talk about all the parts of the ML platform in the blog post, but when you look at what the actual like infrastructure diagram, the architecture is, it's like 80% of it is related to like feature stuff. There's a whole bunch of stuff around regularly computing features, putting it into online. We used Cassandra for an online feature store, so storing it there, having a feature server, be able to pull those features, do some real-time compute on that, like all kinds of stuff. And then there's like some little part where it's like, and we'll do model training and we'll do model serving. So a lot of the work in these systems, depending on how you define the scope of your ML platform, is all of this data stuff for sure.
I need to ask you, Mike. I asked Aurimas this question when we met first time. We met first time on our podcast. Aurimas was a guest, and I asked Aurimas why we are not including model serving as a part of feature store. You just did it like you also pick it like that. Feature store and serving part, right? At the same time, you said before that some of the feature transformations are quite complex. What is the difference? Why a model inference is not just a complex feature transformation?
It kind of is. It's honestly, it's not like there's no like big religious like element here where we're not in a position where we would say for sure we would never serve a machine learning model or something. I think for us though, we found, so okay, let's fast forward to like today. I run a company called Tecton. So basically from doing all this stuff at Uber, Michelangelo, we recognize the value of all this feature engineering part of the ML platform. And so myself and the eng leads of Michelangelo, we left Uber and we started Tecton. And so Tecton is all about building kind of like the industry's, leading enterprise feature platform. So basically solving all those problems for somebody else. And if you go to like a Google, like I was saying, there's literally hundreds of engineers working on this stuff. You go to Facebook, they have hundreds of engineers working on this stuff. And we see ourselves as just like literally just, and our team is made up of people like who worked on those things. And we're just building that level of quality of infrastructure, the same reliability, performance, simplicity, and extensibility, and just making that available to kind of everyone who's trying to do, real-time machine learning. So, so why do we focus on that and not also machine learning models? And machine learning model serving and stuff like that. And so I think it's a little bit based on being very careful about the scope we choose. And the reason we have to be careful about the scope we choose comes back to a little bit of a lesson that I got from a mistake we did in Michelangelo. In Michelangelo, we built this end-to-end ML platform, which was cool. And we built it a little bit for like our first users, and it worked for the first users. And then, we go to users like teams 4, 5, and 6, and they go, yeah, like that's really cool. Like I like your thing, but I need a different way to do the serving, or I need a different way to do the training. And so Michelangelo at the time was this big thing. Imagine 8 different steps in the machine learning pipeline. You can, break it up however you want, but the chances for, if you're a new team, the chances that this whole thing is going to be a perfect fit for you in every single stage. Imagine each stage is 90% chance that it's going to like match your requirements. You kind of have like a 0.9 to the power of 8, right? 0.9 times 0.9 times 0.9. And so the realistic kind of end goal or end chances that the whole platform is going to work for you is actually pretty low afterwards. So we quickly realized we needed to break this thing up into different parts, make it more modular, so that people who have different requirements, because machine learning is a whole thing where every use case has different requirements. There's never 2 use cases that are the exact same, no matter what people say. And it'll be like, yeah, but I need to serve this model on the phone, or I need to serve this model in this way, or yeah, but we train with like a special kind of hardware, and what, or at Uber it was we serve the model on the car. We were doing self-driving cars at the time. Any kind of thing, or we have a different kind of feature. Our features come from some other place. So we needed it to be like able to swap something out and swap in your custom module. And so uh, in breaking up Michelangelo, one of the things was just all the feature logic, all the feature infrastructure, and we found that the feature, now like looking broader, coming back to the tech, to the kind of like feature platform as a product in the market today, we found that the requirements that someone has with their feature engineering are not always super correlated to the requirements someone has for their model serving. So they're not like the exact same, they're not like highly correlated. So what I mean by that is there's people who will need a certain type of feature engine, like what you need in your feature compute and your feature from your feature infrastructure doesn't imply a lot about what you need from your model serving. And there's a whole space of different model serving things that you can do. And if you look in the market, there's 100 different companies that do model serving. We can probably name a bunch of them really easily. And so we thought, why, that's not our specialty. Let's just be really good at plugging into those things. I do think that in the future, we don't have anything against like, yeah, and we can also serve models, but I don't think like what we have built is necessarily like changing the game or a 10x better thing for model serving. And also as we kind of move forward now, we're seeing model serving and inference generally become a more complex thing, especially with GPU-based serving, bigger models, all of that.
Large language models, definitely.
Exactly, and it's just a deeper problem. And that means you're going to have more specific requirements for that, and that requires more and more focus. And so we're staying focused on our domain because we're kind of like really the only player that's doing this, like really at this quality. But I do expect like someday we'll move into that for sure.
I understand this argument it is very well, because with Neptune, we are experiment tracker, right? We are also point solution. We initially, when we started Neptune, Neptune was a spin-off of my previous company, and it had infrastructure management part that would help, that you could use to train your models. But we also, like for the very similar reasons, we decided to drop it and focus just on that.
Yeah, why should I buy a part when I can buy the whole thing from somebody, right? And I'll tell you, yeah, my answer I think is pretty simple. I think you got to kind of take you got to make a bet. You have to use some judgment on like how you think the machine learning market and the machine learning technology stack is going to evolve over time, right? And for us, I think the kind of the take that we have is that everything that's going on in ML ops, if you look at, this is the standard, everybody knows this. You look at the kind of like landscape diagram, and there's 4,000 companies, and maybe they'll be like bucketed. That's true, but you'll see like a box with a bunch of companies in it, and all those companies will kind of do different things, and so the geometry of different products is kind of unsettled. And I feel like we're going through, as an industry, like an annealing process, like a converging process, where we're slowly, some companies are working, some aren't working. We're kind of forming into what are the layers of the stack that the industry will converge to and will kind of be stable long-term like elements of the stack. And so my position on it is, of course, there's going to be some end-to-end ML platforms, but we're not really seeing end-to-end ML platforms work in for production purposes. People who are doing like real production in ML, and I'm talking about people who like are our customers, who are like, they're predicting fraud, they're doing recommendation systems, they're doing dynamic pricing, things like that. The variety, the variance of requirements, if you look at those use cases, is just so high that it's really hard for all-in-one system to ever be good enough often enough for many use cases, many customers. But we think that it's a lot more possible for you to build a really high quality system. And similar for experiment tracking, you could build the best experiment tracker and it could be good for all of those. But it's really hard to build the best experiment tracker and the best monitoring thing and the best training, whatever, all of those things, and have it all be. So that's just a bet that we have on how the industry is going to look 5 years from now. I think for production machine learning use cases, it's going to be mainly driven by components of an ML stack that are that work really well together, and combining best in class solutions rather than just like I don't think there's going to be like an all-in-one ML production ML platform that everybody uses.